Hello everyone, welcome back. Today we have 169 majority element. It says here that we're given an array nums of some size n. From here we are to return the majority element. The majority element is the element that appears more than n divided by 2 times, so more than half times. You may assume that the majority element always exists in the array. So if we have three items, odd number, the majority element should appear at least twice. If we have an even number, let's say 1, 2, 3, 4, 5, 6, 7, so this is odd. But let's say we just had 6, we need the element to appear more than half. Half is 3, so it should appear at least 4 times. All right, let's take an example here. Of course, the simplest approach is one where we, determine what the majority count would be, then get the count for each number, and then make another loop to see which of the counts qualify as a majority element. And because to be majority, it must be over half, you will have exactly one answer. All right, now there is a better way using a voting algorithm, but let's quickly run through the most intuitive way first. Okay, so the first way is just, collecting the counts and saying for num in nums, all we're doing is saying the counts of that number will be 1 plus whatever it is to start, which is whatever the count is, or 0 to start. So at this point, we have the counts of each num in nums. And then to be majority, it must be at least length of nums divided by 2, and then plus 1. Okay? And then we do the second loop, iterating through the counts and check for the num and the count in counts.items. We're iterating both. If the count is greater than or equal to what qualifies it to be a majority, then we can return num. And we are told that there is an answer, so let's just say this will always have an answer because we are guaranteed to have it. We'll say num res is equal to num, and we can break. And at the end, we can return res. And let's run and submit. Okay, now this does work. This is time and space both are linear O of n because we do have this hash map and then we do run through twice, but that comes down to it's 2n, but it reduces down to O of n. This is one way. There is another way, and the other way relies on the fact that we're looking for an element that appears more than half times. So for it to appear more than half times, as long as we keep track of whatever the current element is, let's say the current element is 2, as long as we keep track of whether the count of whatever number we are currently on, if that count is a positive, then whatever is still alive at the end of the iteration, that has to be the majority element. Let's say we have, we increment by plus plus, and then we got an element which was not itself. Then we crossed that out, and then we got it where it was itself. Then, I don't know if this makes sense, but at the end of the day, whatever positive action and cancel out action occurs, if it is the majority element, it will be plussed enough times that it will survive at the end of this iteration. So let's run through. Let's have a live example here. So we're at 2. Okay, so we start at 2. In fact, we start at whatever is the first number. Let's say our number is 2. And we say the count is going to be 1 to start. Okay, so in fact, we don't start at this 2, we start at the second 2. Okay, we start at the second value. All right, so is this current value the same as whatever the current number that we're tracking is? If so, then we can increment the count. And when we increment the count, this becomes 2, and then we can move along to the next number. Now this number is not the current number. So instead, we have that plus and cross out action. We can apply the same where we, instead of incrementing, because this no longer matches the current number, we can actually decrement, and now this becomes 1. Okay, we can move this to the next number, which is 3. 3, once again, does not match the number that we're currently tracking, so we also need to decrement. And so now this becomes 0. Note that at this point, whatever number we're tracking is no longer a majority element. Its count is 0, and you can see it here as well. You can see that so far we have 4 numbers where 2 appeared twice, and some other number which was not 2 appeared twice as well. So we know that this can't be the majority because out of the 4 numbers, for it to maintain its majority stake, it should appear at least 3 times. Okay, so let's continue and move this, move that guy along to the next number. All right, so now we are technically at 2, which was the number we were previously tracking. However, because the count is 0, if this happened to be a different number or this number, it doesn't matter. We need to reset it. The current count is 0, meaning there is currently no majority number. So let's update to our new number, which is 2, and reset this to 1. We're basically starting again. Okay, so that was our point. Now we're at another 2. Does this match the current number? It does, so that stays. And the count is a positive, so it is still the majority. We just have to increment this number. And after we increment, we get a 2. And at the end, we have our final number, which is a 3, which does not match the current majority. And that's okay. All we have to do is decrement this guy. It becomes a 1. And at this point, the number that's still alive at the end of this, still alive meaning it has a count of at least 1, and we're guaranteed to have one number that survives this, and that happens to be a 2. Now, it doesn't, once again, it doesn't matter where or how these numbers are grouped, because let's say, in fact, let's try something here. Let's say that all the majority numbers are at the beginning, right? What would happen then? Just for demonstration. Okay, so we would have, we would start at the first one, that's 1, that's plus, 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 and a plus. And at this point, the number would be a 2, and the count would be a 4, where afterwards we would minus, minus, minus. However, even after subtracting 3, you'd minus 3, that's still a 1. So this is still the majority number. Okay? And likewise, let's say that instead all the majority numbers were actually in the back. As in, let's bring that guy over here and that guy over here and this guy over here, this guy over here. You go here. Okay. All right. And once again, all right, so when we begin, now in this case, all the majority numbers are at the end. This is just to emphasize that the order does not matter. The number that's currently the winner is a 3 with a count of 1. Okay, and here, this will increment to a 2. but then it'll decrement because 1 does not match with 3. And then at this point, this will decrement yet again to a 0, after which, once we hit here, because the current number is a 0, these both will reset. Once they reset, the number becomes a 2, count becomes a 1, then we'll add once more here, another times here. This will be incremented twice to become a 3. And once again, this is the winner. So the order doesn't matter. The main idea is whatever the majority element happens to be has to appear greater than 50%. And by doing so, the plus and minus action will eventually cancel out in favor of whatever the majority element is. Okay, so now let's get to the code part. What we did was on here, we always took the first one and said, hey, doesn't matter what we start with, we'll eventually end up with whatever appears more than 50% of the times anyways. So let's just start from the beginning, set that as our potential majority element, and then iterate for each num in nums. But remember, we're skipping the first one because that's what we're starting with. So we iterate from the second one onwards and say if the number that we're currently on matches whatever number we're currently tracking, let's say, that's the major, then we increment, okay? Otherwise, if count is 0, we're at a point where the count is 0 and we need to reset it as whatever the new number is and the count of 1, the starting count of 1. So if the count is 0, then the new majority element is whatever the current number is, and count will reinitialize to 1. Otherwise, it's neither of these cases, then that's okay, we just decrement. As in, it's not the same number, nor is the count 0, right? Which means that this is a positive count, which means whatever the current number is still the majority element. Until that dips to 0, we indeed still do have a majority element. Only when it dips to 0, we don't have a majority element. We can reset the major and the count. Okay? And at the end of this, basically, whatever survived this iteration is the winner. It's the one that appears more than half times. We can submit. And there you have it. This is once again 169 majority element, whereby doing it this way, we get a time of linear. Time is linear and however, the space is constant. We are not storing a map of counts. Thanks so much. Happy coding. See you next time.